Hey there, class. This is our example SPSS video of what we do when we have a factorial ANOVA with a significant interaction. You can find all the documents I'm going to go through on Canvas here under the interaction effects. The example two-way ANOVA with an interaction that we're going to go through is on here. You can follow along with what I'm doing in this document where I've fully annotated all of the SPSS output for you. Also on Canvas is a step-by-step guide for running a factorial ANOVA in SPSS. So it gives you, the steps to run the main analysis, and then it gives you how to conduct the simple main effects analysis. To do that, we're going to have to adjust some syntax. You can see down here is a screenshot of the syntax that we're adjusting. We're going to walk through it, and I think it may make a little bit more sense. But I just want to show you where all of the documents are. Our example data set you can download is here. Whoops, sorry. Back to the interaction effects. The data set's here, the example two-way ANOVA with an interaction. There's the data set. Our results section is saved here, so you can see for this example how you might write up the results for this analysis. You can see those saved here on Canvas. And I've also provided the SPSS syntax file to run this simple main effects analysis, so you can follow along there too. So if you look at the syntax file, here's the syntax for the overall ANOVA, and here's the syntax for the simple main effects analysis, where we have to add this little part to the syntax. Like I said, it'll make a little bit more sense when we get to it. I'm going to actually close this out so you can follow along with me. So let's look at the example and walk through it together. Well, here's our example. So a researcher is interested in whether 3 methods of teaching are equally effective for students with different reading levels. So students from high, middle, and low reading ability levels are randomly assigned to 3 different teaching strategies. The researcher hypothesizes that the effect of the teaching strategy on students' math achievement will depend on their reading ability. So that's the interaction hypothesis there, right? The effect of the teaching strategy, one of the independent variables, is going to depend on the student's reading ability, the other independent variable. So at the end of the semester, the students take a standardized math achievement test. And so our independent variables then are the type of teaching method A, B, or C, and the student's reading ability level, whether they have high reading ability, middle, average reading ability, or low reading ability. And so higher scores equal greater math achievement. So this would be what we would call a 3x3 between subjects factorial ANOVA design. And so to enter these data into SPSS, notice that person 1 here was taught using teaching method A and was in the high reading ability group. And they had a 24 on their final mathematics achievement score. This next person who was taught with teaching method A was in the average reading ability group and got a 30 on the test, on the math achievement test. So let's first notice how we enter the data into SPSS. Remember, each row in SPSS represents an individual, and each column represents a variable. So our dependent variable is math achievement here. One of our independent variables is reading ability level. So whether it was low, medium, or high. And we can see how do we have these coded. We actually have high coded as 1, middle coded as 2, and low coded as 3. You could have done it the other way. You'll get the exact same results. So it doesn't matter how you code these, just as long as you remember 1 was high. And then 1 here again represents teaching method A, teaching method B, and 3 is teaching method C. I think I just coded them in the order they appear in this document here. High was the first group, middle was the second, low was the third. I think that's why it's 1, 2, 3. But like I said, it doesn't matter how you do those. Remember, person 1 was in reading group, was the high reading group, taught with teaching method A, had a score of 24. The next person, over on our list was in the middle reading ability group. They were taught with method 1 and they had a score of 30. That is this individual here who's highlighted. So just take note of how you actually enter the data into SPSS. We have to indicate what reading group they're in, what reading ability they have, what method they were taught, and then their final math achievement score. So to run the analysis, we do the same way, the overall ANOVA as we did with the Factorial ANOVA with no interaction effect. We've got to analyze, general linear model, univariate. We bring over our dependent variable math up here to dependent variable, and then our reading and method over here to our fixed factors box. We click on the EM means tab and get our estimated marginal means for each one of our variables. So we could have, so this would be our main effects, and then these would be, if there is a significant interaction effect, the cell means to plot would be here. If you're using SPSS 24 or lower, these options in EN means, we're in options here. We can ask for descriptive statistics, estimates of effect size, that gives us a partial eta squared, homogeneity of variance test, which will give us our Levene's test. We can click continue. We can also click on plots here and get a visual representation of what the interaction might be. So if we want to know whether mathematics achievement varies by whether the type of teaching method, the impact of the type of teaching method on mathematics achievement depends on the reading group they're in. So we'll put teaching method on separate lines and our reading ability group on the horizontal axis. We'll click add, and I always like to include this option, start the y-axis at 0. And then let's click OK. All right, took it a minute to run here. So we can see just some descriptive statistics. We knew that 15 students were randomly assigned to each one of the teaching methods. So, we could use this to see, if we have anything miscoded, we can go back and check. We get descriptive statistics for, the high reading ability group, method A, B, and C. Oops, take that off. So the next thing we'll look at, or the first thing we'll look at is this Levene's test of equality of variance. We're going to read the first line based on the means. If we're really worried about that our data aren't normally distributed, we might read this line based on the median. Here it doesn't really matter. We come to the same conclusion either way, that the population variances are equal across our group, so we meet the assumption of homogeneity of variance. The next thing we would look at is our reading by method interaction term. SPSS represents it with a product term here. We go over here and we see that there is a statistically significant interaction effect. So when there is a statistically significant interaction effect, we are going to ignore the main effects. We're going to plot the interaction just to get a visual representation of what it looks like, and then conduct a simple main effects analysis. So these estimated marginal means, these would be your main effects for reading ability level, ignoring the type of teaching method. These would be the main effects for each teaching method, ignoring their reading ability level. And then here are cell means that we're actually going to graph. So, you know, for the high ability level group, these are the means for each of the different teaching methods. For the middle ability group level, these are the means for the 3 different teaching methods. Same thing for the low ability group. These are the means for the 3 different teaching methods. And that's what's graphed here. You can see for the high ability group, the means were all pretty close to each other. Same thing for the middle ability group, the means were all fairly close. And look at the big distribution for the low group. That's what we're showing here. So basically our simple main effects analysis, what we're basically doing is we're going to select on just those in the high ability group and conduct a one-way ANOVA, examining mean differences across these 3 means. We'll select the middle ability group, look at mean differences across these means. Select the low ability group and look at mean differences across the 3 different teaching methods for the low ability group. If you remember our interaction hypothesis, you know, is usually if there's no interaction, usually the line segments are parallel. You can see how they kind of all diverge here, especially with this method indicating an interaction effect. So to conduct the simple main effects analysis, we're going to actually use some syntax. You can't do it through the pull-down menu in SPSS. What we'll do is go back to our Analyze General Linear Model Univariate. All of our settings that we just chose last time should still be in there. If not, we'll have to go through and select all of them again. Instead of clicking OK, we're going to click Paste. And it should paste this in a syntax window. Like this should come up. And what we're going to do then is modify this line where that says EM means table. We're going to look at the interaction effects line. What we're going to do is we're going to tell it that we want to compare the different teaching methods for each reading ability level, compare the different teaching methods, and we want to adjust for multiple comparisons using a bond for, there we go. If I spell it right, it'll work. Using a Bonferroni correction. If you look in the, so you can see in my walkthrough here, I walk through all the analysis. There's how you're calculating the plot. You know, we go through the same thing, and then, you know, we're going to edit this line in the table where the interaction term is, and you can add. So the adjustments you can make are, you can do a SEDAC adjustment, which is very similar to Bonferroni. You can do a Bonferroni, you could do adjust Bonferroni, or you could do adjust LSD, least significant differences, which basically means make no adjustment to the p-values. For whatever reason in these screenshots, I I said adjust using SADAC, but then in the output, I use Bonferroni. So go figure. So I'm going to do Bonferroni in my example here, so it'll follow along with what's reported here, if you're following along with that output. So let's go back to our syntax file. We've added compare, method, adjust, Bonferroni. And then what we do is we just highlight this syntax and push this green arrow to run this selection. And then our new output will appear. Everything's the exact same as we had before. Notice there's our descriptive statistics. Our means test is the exact same. The test of between subject effects table is the exact same. Notice the interaction term is still statistically significant. What's new here is this pairwise comparison test table and this univariate test table. We're going to look at the univariate test table first. So this is basically then the results of 3 separate one-way analysis of variance. First, selecting on just those with high ability levels. We're selecting on just those with high ability levels and looking at differences between teaching method A, B, and C. We have this F test. So we're basically looking at the mean difference between these means right here. This F test is saying that there is no significant difference between those means. So essentially, teaching method A, B, and C are equally effective for those with the high ability reading level. The second univariate test is comparing teaching methods A, B, and C for the middle or average reading ability group. So it's comparing these means right here. We'll look at the significance level of that F test, and it's saying that there is no difference between those means. So the teaching methods are equally effective for the teaching method A, B, and C are equally effective for those with middle or average reading ability levels. This last univariate F test is looking at differences between teaching methods A, B, and C for those in the low ability reading group. And the F test is saying, yes, there are significant differences between the 3 different teaching methods for those in the low ability group. And it's looking at differences between these means. Just looking at these, it looks like, method C seems very much superior for those in the low ability reading group. Since there's more than 2 groups here, we need post hoc test, and that's what we had asked for in that syntax. We asked for post hoc test and to do a Bonferroni adjustment, and that's what these are here. So these p-values have already been adjusted for multiple comparisons using the Bonferroni adjustment. So we can see that teaching method A and B are significantly different, teaching method A and C are significantly different, and teaching method B and C are not statistically different than each other. So teaching method A is significantly different than B and C. What was that? Yeah, teaching method A is significantly different than both teaching method B and C. B and C seem superior to teaching method A, but teaching method B and C seem equally as effective for those in the low ability group. Here you could also calculate Cohen's d effect sizes for these pairwise differences. And so you would just do the mean difference. So this reduced between A and B divided by the square root of the mean square error term from the full model. So we want the mean square error term from, well, you could get it from here too, because it's the same thing, 62.5. But it's also the mean square error from the full model here is what we're going to divide as our pooled estimate of variance. So if you wanted to calculate Cohen's d effect sizes for those group differences, you could take the mean differences reported here between A and B is 20 and divide it by the square root of 62.5, the mean square error term. And you can see those calculations here. So we see those who are in the lower reading ability who were taught using method B had math achievement scores almost 2.5 standard deviations higher than those who were taught with method A. Is what that's saying there. That's all the same thing. We are saying multiple comparison table here. There's our same profile plot. We also have, partial eta squareds for each one of these models. Which would say, so this one is saying then for those in the low ability reading group, differences between teaching methods explained around 53.7% of the variability in math achievement. We also have variance explained effect sizes here. We can get one, here it is for the full model. The reading ability level, the type of teaching method, and the interaction between reading and teaching method explain around 47% of the variation in mathematics achievement scores. Is how you would interpret this adjusted R squared for the full model here. Same thing, just the interaction between reading and teaching methods explaining around 35% of the variance in math achievement scores. So just to kind of summarize, for any factorial ANOVA, the first thing we look at is the significance level of the interaction term. If the interaction term is significant, we're going to ignore these main effects and conduct a simple main effects analysis. So what you can do is just go back to your analyze general linear model univariate and paste your syntax into a new syntax window. And then we need to go to the EM means line for the interaction term, and we want to compare, and we would choose one of our independent variables. So this time we want to compare different teaching methods within each reading level. And for the assignment, I'll tell you which variable I want you to compare, but you could also do it the other way, compare, read, adjust, Bonferroni here, and you'll get, now you'll get, for each teaching method, are there differences in math achievement scores for each reading ability level is what you're answering here. See, so for teaching method A, there's a significant difference between reading ability levels. For teaching method B, there's no difference in mathematics achievement scores for the different reading ability levels. And then for method C, there is a significant difference in mathematics achievement for the different reading ability levels. And you would see those. the pairwise differences here. So it depends on kind of what you're most interested in. Do you want to compare? I think it makes more sense for us. We want to compare, you know, within each reading ability level, how effective is each one of the teaching methods. Here we're looking at, for each teaching method, how do the different reading ability groups compare on their mathematics achievement. So it's kind of getting at the question in just a different angle. But either one of them is technically, I guess, correct. So, you know, summarize again, first thing we look at is the significance level of the interaction term. If it's statistically significant, we're going to ignore the main effects. Always plot your interaction so you can kind of see what's going on. And then really the variable that you're wanting to compare, always put on separate lines. Like here, we put method on separate lines because that's the variable that we're wanting to compare. And so we can see within each ability level, how do each of these teaching methods compare. You know, as always, if you have any questions or concerns, please email me, post a question to the message board, and I'll see you at the next time. Thank you.